Greetings to Dr. Fong. My name is Choong Kai Jie, and my teammates include Lai Yi Jun, Chong Lee Xuan, and Sia Yong Wei. For our video assignment today, our group will be presenting about the application of matrix algebra in real life in this video. I will be presenting about the application of matrix algebra in photography and image processing. Matrices are two-dimensional arrays of numbers that are used to represent images in digital image processing. They are used in many tasks including image storage, filtering, and transformation. Firstly, the application in photography includes image presentation, which is an image is a matrix of pixels arranged in rows and columns. Each pixel is an element of matrix. Next up is the application in 3D graphics, which is the matrices can be used to store and apply transformation to vectors, which represent points or directions. For example, in a 8-bit grayscale image shown in the picture above, each picture element has an assigned intensity that ranges from 0 to 255. A grayscale image is what people normally call a black and white image, but the name emphasizes that such an image will also include many shades of gray. Secondly, its application also includes in digital image processing. For image transformation, matrices can be used to resize, rotate, and reposition images. This is done by multiplying the image matrix by a transformation matrix. For example, you can add a constant to each pixel's red, green, and blue values to increase the brightness. For image filtering, matrices can be used to apply filters to images. For example, you can apply a black and white filter by averaging each pixel's red, green, and blue values. You can also use convolution to extract features of filter images. To bring clarify to my point, I will have to use this picture as a reference. A matrix is a two-dimensional array of integers used in image processing to represent the pixels in an image. The value of each element in the matrix correlates to the intensity or color of a certain pixel, with each element representing a particular pixel in the image. By multiplying the image matrix's pixel value by a filter matrix, one may apply picture filters. Similarly, one can execute image transformation by multiplying the image matrix pixel value by a transformation matrix. As you can see the differences between the picture before applying the filter and the picture after applying the filter itself.
My name is Lai Yi Jun. So now I want to talk about the applications of matrix algebra in engineering field. Firstly, for structural analysis in civil and mechanical engineering. In structural engineering, matrices are used to solve systems of equations that model the behavior of structures such as bridges, buildings, and dams. For instance, matrices represent the stiffness of beams, force applied, and displacement of structures. Next is the finite element method, FEN. This method is used to break down complex structures into smaller, manageable elements, and matrix algebra helps to calculate the stress, strain, and the displacement of each element. Next is matrices are used to model and analyze dynamic systems, especially in the design of controllers for systems like robots, aircraft, or manufacturing processes. The state space representation of system A, B, C, D matrix describe the system state variables and their relationships, allowing engineers to design feedback loops and stability analysis. Besides that, eigenvalues and eigenvectors are critical for analyzing system stability, resonance, and other dynamic properties. In addition, is in the physics fields. Let me start with quantum mechanics. In quantum mechanics, the state of particles is often represented as a vector in a Hilbert space, and physical observable light positions, momentum, and energies are represented by operators which are metrics. The Schrödinger equation can be solved using matrix algebra. In spin systems, spin operators which describe the intrinsic angular momentum of particles are often represented by matrix, which is Pauli matrix. They are used in quantum computing and particle physics. Next is about general relativity and gravitations. In general relativity, the geometry of space-time is described by tensions, which are generalized metrics. The Einstein field equation, which convert to gravitational interactions, are written in tensor form and require matrix operation to solve in various scenarios, such as black hole dynamics or cosmological models. Lastly, for transformations of coordinates, matrix transformations are used in relativity to change coordinate system, especially when dealing with curved space-time.
Hi, my name is Lee Xuan. Now, I would like to talk about how metric can be used in economy and business. In economy and business, we can use metric to describe how industry in an economy depends on each other to produce goods and service. It tracks the flow of inputs such as resource and output such as goods and service among industry. Metric can be used for economy input and output analysis. This is the formula used. A represents the input-output matrix, which is coefficient showing how much each industry consumes from others. X is the output vector, which is the total production of each industry. D is the demand vector that final goods demand by consumer. The last one, I, is the identity matrix. This is the example. First, we consider two industries, agriculture S1 and manufacturing S2. The input-output matrix are given. Now, if consumer demands D given, we need to solve for X using the formula. So, this is the solution. First, we need to compute the I minus A. After that, we need to find the inverse of I minus A. At the end, we need to multiply the inverse I minus A by D. So, we can find that the agriculture S1 must produce 115 units, and the manufacturing S2 must produce 165 units.
My name is Sia Yong Wei. So the transportation also is an application of metric algebra. Matrix representation of urban traffic, application of smart traffic light, congestion analysis, and traffic flow optimization. Example, HSS matrix is can use to represent city route network. Traffic flow between intersections is monitored and the data is stored in matrix to adjust signal timing dynamically. Example, AI-driven systems like Google Intelligent Traffic Control use real-time matrix data to manage congestion and reduce the travel time. So the HSS matrix purpose is represent to connectivity between intersections or not in route network. Example, a city with four intersections A, B, C, and D, where S is connected to B and C, B is connected to A, C, and D, C is connected to A, B, and D, D is connected to B and C. So the HSS matrix A equal to 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0. So we can get I multiply J can get 1. There's a direct route between intersection I and J. And other is I multiply J is equal to 0. So there's no direct route exists. So that's all for today I will present. Thank you.